Welcome to this online presentation for Oscar II design for Washington State. Outline for today's presentation is discuss what a Oscar II is, treatment level, soil depth requirements, also combining other technologies for higher treatment capabilities, and some training steps for designer install as well as operation and maintenance personnel. Oscar stands for an on-site sand coil area recharge. Describes kind of what it is and what it does. The Oscar is also a proprietary technology that is meant to treat not only fecal coliform but also BOD TSS to 2 respectively for milligrams per liter, and it also acts as a final disposal component. The two green and blue bars represent the influent BOD and TSS for the treatment tests. The smaller bars, the yellow and light purple, are the discharge from the Oscar. We started at over 220, 230 milligrams per liter BOD TSS, and we averaged throughout the entire test 2 for BOD and TSS. Fecal coliforms influent ranged from somewhere in the 6 to 7 million up to almost 100 million. Our average daily coming out ranged from a low of 100 fecal coliforms per 100 mils to our high in the 6-month test of just over 1100. The Oscar has two components. One is drip coils, Metafim, BioLine with 6-inch emitter spacings, and we use the 0.42 gallon per hour emitter. And we have two coil versions. One, the 5-foot diameter, or the OS50 at 50 gallons a day, and the OS100 at 100 gallons per day. The other component is ASTM C33 sand with a minimum of 6 inches underneath of the coil. The 5-foot or OS50 coil, once assembled, will have this shape in the field. Again, the green is just a background for contrast, and the white bracket that the tubing is actually attached to is just that, a bracket to hold it in its shape. The OS100 is very similar. The only difference is we've got twice the amount of coil, and again it will be attached to the bracket and it'll have this basic shape once assembled in the field. Now the OS50 again is rated at 50 gallons per design, 50 gallons a day for the design flow, and it covers a 5-foot by 5-foot area with 50 emitters, and it works out to about 2 emitters per square foot per day. The OS100 is a 100 gallon per day design flow in a 50 square foot area, roughly 7 by 7, with 100 emitters, and again with the same emitter concentration of 2 emitters per square foot. Now, both the OS50 and the OS100, regardless of the coils that's used, you're going to have to design for the same basal area, but the dimensions will be different. For instance, looking at using the OS50 on a 300 gallon a day design flow, the minimum length of the basal area is going to be just under 35 feet, and we can use the OS50 in as little as 12 inches of native soil. Contrary to the OS100, again using the same design flow, their length is going to be just under 25 feet, so there's a 10-foot savings in just going from the OS50 to 100. The only issue is the OS100, you have to have a minimum of 18 inches of soil in order to be implemented in Washington. And to give you a visual of what those two would look like, and these would be for flat sites. Both of these basal areas represent the same square footage, but obviously you can see the dimensions are going to be significantly different from length to width. The Oscar from a side view, we have the red line, horizontal line representing the coil itself, minimum of 6 inches of sand underneath that, overlying a prepared basal area or receiving soil. You'll notice that the areas outside of where the coil is located is just a minimum of 6 inches deep. The only place that we have a total of 12 inches is right with the coils. we're going to have 6 inches under, as well as a minimum of 6 inches on top of the coil. But again, the rest of the basal area, we only need to have 6 inches. And a look at, again, the 300 gallon a day design with the 7-foot coils on a sloping site. You can see we've shifted the coils up to the upper elevation basal area boundary, so we take advantage of all of the potential basal area infiltration as water moves down slope through the soil profile. Our tankage with a standard 500 gallon a day system is going to be a minimum of a 1,000 gallon treatment vessel. We'll talk a little bit more about that criteria, and a 1,000 gallon dosing tank. We do utilize the reverse flush headworks. That's similar with the low flow system, and then the Oscar drain field in addition to that. So you got a little close-up of the tanks, and this is how we would actually like to have the plumbing done with the headworks between the two openings in the discharge tank. It's just a clean way of putting it together. Now currently the Oscar 2 is approved for treatment level C. Treatment level C under the DOH requirements are 25 CBOD, 30 total suspended solids, and anything over 1,000 fecal coliforms up to 50,000 will put you over the limit. Both BOD TSS were well under those limits, but again we had 1 month that were of the 6 were over the 1,000 mark. So just use the way it's approved on the list. You would need a minimum of 24 inches of vertical separation. But if you combine the Oscar 2 with another technology, for instance, with an ATU that meets TLB on its own, by combining the Oscar 2, we can take advantage of the Oscar footprint and the TLB soil depth requirement of the treatment unit. So again, when we do that, then the OS50s can be used with as little as 12 inches of soil depth. The OS100s, again, we need to have at least 18. Now we've put together some standard packages to make the design, installation, inventory, manufacture, and review of the Oscar designs much simpler. We've removed lots of variables. So when we go through this review process, we're going to be looking at, again, the standard packages. Briefly mention the setbacks. Basal area calculations is the one thing that's going to have some variability. Hydraulic layout pretty much is standard depending upon the design flow. We will have to design for the, or at least calculate the total dynamic head for the Oscar supply line. And then we'll look at the tankages, the treatment vessels that may be appropriate to use. Now our standard package includes a control panel, and this particular control panel, the LF1P RF BLWR, can actually operate not only the reverse flush headworks in the dosing pump, but also power a blower, and it also has a pressure switch in there. So it can be used with a number of different treatment technologies and operate the electronics for that as well. Again, the headworks, reverse flush headworks will be included in the package. We use the standard AY McDonald 30 gallon a minute turbine pump. We also include a 3/4 inch flow meter, and also some floats, some blank tubing, float brackets, also some transition fittings for the Oscar tubing to the PVC pipe. And just real briefly, we have the same setbacks as we would for a mount system that's listed in our design manual. But here's kind of just an indication of the types of setbacks that we would need to have for property lines and so forth. Now our standard coil arrangements, for instance, if we use a OS 240 gallon a day with 5-foot coils, that's the OS 240-5, that's going to be the same coil arrangement in soil type 1 as in soil type 6 as well. The same coils are going to be used, but the basal area itself will change. Obviously the soil type 6 is going to have a much larger footprint than the soil type 1. So I'll give you an example or a sample design here. We'll stick with the design flow of 240 gallons a day. Our fictitious site will have 15 inches of soil depth to the restrictive layer. And we'll give two examples, one for a flat site and the other one for a max of 20% sloping site. And we're going to use this same basic coil layout that's depicted here. The first thing we want to do is calculate the basal area, and that's done simply by taking the design flow rate divided by our application rate of receiving soil. Here we're going to use soil type 4, so we're going to need a minimum of 400 square feet in our basal area. So now we've got to figure out what the actual dimensions of that basal area are going to be. The first thing we need to determine is the minimum shoulder length. That's going to drive the minimum length of the basal. And you can see here depicted the minimum shoulder length is basically that distance that includes all the coils, the separation between the coils, and the shoulder setback on either end of this row of coils. If we refer to the table 3 in our design manual, we have these listed by design flow, and we give these minimum shoulder lengths in feet so that they don't have to be calculated. So a 240 gallon a day system must have at least a 28 minimum shoulder length. The only thing we have to do extra is add on, because we're building sand above the ground, we're going to have to compensate for our side slopes. Because we're looking at a minimum on a flat side, a minimum of 6 inches of soil or 6 inches of sand, each side slope is going to be worth 6 inches. So we're going to add to the shoulder length twice the side slope of one side slope. So when we go through and look at the numbers, again we start with the 240 a day. We're going to divide that by our 0.6 gallons per day per square foot loading rate with our 400 square feet. Our minimum shoulder length from table 2 is 28 feet. The minimum side slopes, and again we're looking at a 1-to-1 slope. Again, each one of those is 6 inches, so 2 of those is going to equal an additional foot for our side slope requirements. So our minimum basal area length is going to be our shoulder length plus the side slopes. So it's going to be 28 feet plus 1, 29 total feet for our minimum basal length. So then we just need to do a simple division of our square footage, or 400 feet, divided by our minimum length, and that'll give us just under 14 feet. So we'll go ahead and just round up and make the numbers even to 29 feet long and a 14-foot wide basal area. So we can take our standard drawings that are listed on our website and just plug in the numbers, 14 feet wide, 29 feet long. We've got the coil arrangements that already show how the plumbing and connections are to take place with that number of coils. And then we also have the cross-sectional view as well. So your design of your Oscar is now complete, at least as far as the drain field component. It only took just a few seconds with a couple of calculations. Now, on a sloping site, we only have to compensate for two things. One, we are going to move the coil up to the upper edge and not put it down the center of the basal area. The other thing is we want to keep the coil level, so we have to add some sand depth to the downslope side of the coil. So here we can see on a 20% slope, we needed to add an additional 12 inches of sand to the minimum 6 inches that we started with, so that we have an overall of 18 inches under the coil on the downslope side. Very simple formula. We take the diameter of the coil in inches, multiply it times the percent of the slope, and in this case using 20%, we end up with 12 inches. Obviously that number will change depending upon our slope. If we're only a 10% slope, we're only going to have a 6-inch additional sand we'll have to add to the downslope side. And then again, notice that our toe is only a 6-inch deep layer of sand on top of the basal area once we get past the coil. Again, the same type of calculations. We have the same square footage regardless of the slope. The only thing that changes now is instead of having our minimum side slopes, instead of being 6 inches, they're now going to be 18 inches. So 18 times 2 is going to be 36, or 3 foot is what we're going to have to add to our minimum shoulder length to give us a 31-foot minimum basal area length. Again, we use the same equation, square footage divided by our basal length of 31 feet. We end up with just under 13 feet, so we'll again round up. So our basal area really doesn't change a whole lot but it is different enough that we do need to actually compensate for it. So in this case, giving the same soil type, just all we change the slope, is we need a 31 foot long by 13 foot wide basal area. And again, the drawings that are on our website, we'll just pull off, just add the numbers, correct again for the slope, and that design portion is complete. Now, it's suggested that on our designs that we actually do show the calculation for what the minimum square footage is needed by code. That would be the 240 gallons divided by 0.6 to get us our 400 square feet. And then we always should show what the actual basal area will be once the system is installed. If you remember from our flat site, the sloping site is 31 feet long by 13 feet wide. That equates to about 403 feet. With the flat site, we're at 29 feet long, 14 feet wide, or 406 square feet. So this demonstrates that, in fact, our design meets and exceeds the minimum basal area requirement per code. Now, the only other factor that we can't control with our standard packages is the distance and the elevation difference between the tanks and the Oscar that are going to occur on the sites. So we're going to need to calculate and identify what that total dynamic head is for that supply line. In table 1 and also table 2, we have a table both for the Oscar 50s or OS 50s and the OS 100s. In our table, we have what we call the excess TDH, or the amount of TDH we have left over under our pump curve that we have available for friction loss and elevation loss in our supply line for the Oscar. I've drawn a fictitious, or put together a fictitious pump curve here. Just imagine we have an operating point on this graph at about 13.5 gallons a minute at about 80 feet ahead. Within this particular curve, we have an excess head of about 50 feet. That's the blue segment line between our operating point and the pump curve itself. So as long as our supply line total dynamic head is less than the distance between our operating point and that curve, this pump will work in that application. Again, total dynamic head is going to be your friction loss. You can use either the Hazen-Williams formula or tables, and then your elevation difference between the liquid level in the pump chamber and the upper level of where the Oscar is located. Combine those two values together to come up with your TDH. We are assuming that our supply line flush lines are 1 inch in diameter, PVC, Schedule 40 PVC. Again, the pump in our package has an excess head of about 50 feet, and this is a conservative number, so don't think that you're pushing the envelope if you're getting close to 45 or 40 TDH. And again, as long as if the TDH is greater than 50 feet, we want to identify this as a custom design and identify it and give us a call. We may do something as simple as changing the supply line size from 1 inch to 1.25 inches. Or if it's a significant TDH requirement, we may need to bump up the pump size. And if it requires, say, a 230 volt pump, we'll have to make sure that in that package, a 230 volt panel is supplied with it. So it's important that this is identified so that the supply houses give the contractors what they actually need to make the thing work the way you want it to. Now, a custom design can be defined one of two ways. The TDH is over 50 feet, or the design flow is over 480. Typically, the 600 gallon design flows are fairly common, but still probably the first design or two. Once you're over that 480 gallon mark, give us a call. Make sure we've got the right equipment for you. Tanks. This is where it gets a little nuanced. The standard 500 gallon tanks for the Oscar II system, we need a 1,000 gallon minimum size treatment vessel, and you need to reference the specific tank on the design. It's not just a standard septic tank. And then, of course, just a standard 1,000 gallon dosing tank will be required as well. So the treatment vessel has 4 requirements. One, it has to obviously be on Washington's list of approved containment vessels. It also, more importantly, has got to be on the low ridge list of approved tanks. The minimum size has to be 1,000 gallons or greater. But it's important that whatever tank or treatment tank is selected, that it has to have been tested through NSF and demonstrate that through a standard 40 test, it'll meet at least a 100 milligram per liter CBOD and 75 milligrams per liter TSS. Turns out, in order for that to happen, you're going to actually have a treatment device, for instance, a new water. So the B500, which has a volume of 10,000 or 1,097, would meet that criteria. So we could just use the cut sheet as an example here for just the standard B500 new water treatment tank, and the discharge tank again just 1,000 gallons. Now, if the design flows get over 500 gallons a day, we're going to have to proportionally upsize both the treatment tank, treatment vessel, as well as the pump chamber size. But that's a very minor calculation. Again, give us a call. We can help you how to do that. So, using the standard cut sheets, you'd use our tank diagram, identify what the treatment vessel would be, have a separate section or cut sheet for the treatment tank, and then use our standard drawings for the Oscar design or layout itself. And these would be the basis of your design. Obviously, you're going to have some sort of narration, maybe there's other supporting documentation. For the most part, these three documents will be able to tell us, along with the plot plan, what would need to be installed per your specifications. Now, the Washington drawings, I want to go through a little bit of where they are and how we review those. On our website, we have a page called Our Products. When you click on that, that's going to give you a list of, or a choice of several states. We've got approvals in both Washington and Idaho, so choose Washington. And from there, you're going to have a list of the products that we have available. We're talking about the Oscar 2, so we'll select that. And that just brings you down to an area of that page that has a description of the Oscar 2 system itself. It's all going to also going to have our approved list of the treatment vessels, and a link to those manufacturers. We're going to have our design manuals and installation manuals, and then a list of Oscar design layouts. So here's a 360 gallon a day system. We're using the 5-foot coils, and this will be for a flat site. So again, it's generic, so you just have to do the calculations for your basal area, depending on your soil type. And a 7-foot diameter coil, 480 gallon on a sloping site would be a little bit different, but again, it's pretty standard stuff. We're moving that coil to the upper edge of the basal area. We may need to change the number here depending upon what the slope is. This is based on a 20% slope. So if you're less than that, the 23 inches will be reduced. And these are also available in CAD as well, so you can incorporate those into your other packages. And real briefly, the nomenclature for the drawings, OS stands for Oscar Coil. The 3-digit number is the gallons per day design flow. The 5 or 7 indicates the diameter of coil, and the S will stand for sloping site. If there is no alpha identifier here after the single digit, then it's considered a flat site. Cover material over the Oscar is the only thing that's required is C33. You can use some soil, but we want to have a very, if you do cover it, we want it shallow, maybe 2, 3, 4 inches with low organics. It would be appropriate to cover the sand with maybe some straw, get some grass seed planted, maybe some ground cover. If you're on a really steep site, you may want to use some jute mat to kind of hold things in place until vegetation starts to grow. What we don't want to use is topsoil on top of, or excuse me, topsoil mix on top of the Oscar system. Now you can backfill around. I'm going to go back a couple slides. You can backfill around. Go back a few more slides. For instance, on this downslope slide, you could cover that toe with soil. You could also backfill around the upper side, around the sides to kind of even out the slopes. That would be appropriate. We want to keep the minimal amount of cover over the top just so that we've got it's easy for plant growth to get in and take advantage of the nutrients and moisture that's going to be present around those coils. So we can see back where I left off here. Alrighty. So, okay, training procedures for designers, engineers. This sort of training exercise we like to encourage. Also, we're more than happy to take your phone calls, emails. If you have some designs that you've mocked up and you want us to take a look, we're happy to do a review for you. After you do a couple, it's pretty routine. But again, happy to answer any questions that you may have. For installers, it's a little bit more involved. We do have a online webinar similar to this. Once the installer goes through the online training, they give us a call. We place their name on our list of certified professionals. We also have someone come and do a first install training with them. Once the system has been wired, we come and do the quality control, what we call first startup field training. And this should be done prior to the final inspection. We're not expecting the designers or somebody else to do the QC check for the installation. We want the installers to be able to do that so they understand what it is that they know what it's working before they call for inspection. Operation and maintenance folks, we do a very similar thing as we do with the installers. Obviously, they're not installing, but they need to have the aspects of how it's installed with the criteria. Also, we want to go through the startup procedures with them. And we also do some follow-up O&M procedures with the O&M folks as well. And then, of course, we place their names on the list and publish those. On the website, we do have a link called Certified Professionals. When you click on that, you'll have to choose between Washington and Idaho, excuse me. The list will pop up, and the list is basically going to be a list of individuals' name, last name alphabetically, and then we're going to show, it's not on this particular version, but we'll have a column showing the county that they're located in. It's not a limitation where they can practice. It's just a way for the general public to know geographically where they're located. And then their phone number, contact information, and then whether they're certified as O&M, installer, and in some cases both. Now, to give you just a little idea what the Oscar looks like once it's been installed, on the left, it's about the first summer after the system was installed. You can see lush green growth over the coils themselves. In the wintertime, we still tend to maintain that green growth. This is nothing but sand over the top of the Oscars, and these folks actually mow this with a riding lawnmower. We recommend a push mower, but once that sand is solidified with the grass mat and settled in, it's as firm as soil in many cases. And this was a system that was put in mid to early May. When it first goes into operation, you'll see a wetting pattern. And this is obviously where the coils are. We're just getting some capillary rise and some evapotranspiration occurring here. In the summertime, we probably lose most of the liquid that we're dosing to the Oscar to the atmosphere. It doesn't really stay in the soil environment very long. And then this was 3 months later, August, September that same year. The sand is firmed up nicely. You can walk on it, and nothing, no depressions, no footprints. Especially with the where the sod is, it's very firm. So we hope that was helpful. Please feel free to call us or email with any questions you may have. And again, thank you for taking the time to view our training video.